Hey guys, this is Justin here. Welcome to my video. We are on freecodecamp.org. We are under the coding interview prep algorithm section, and we are going to start a pretty interesting series today. So we are starting the sorting algorithms here. We're going to start with the bubble sort and go through these one by one. But today, let's focus on the bubble sort. So they give us this crazy instructions here. I'm not gonna read this, so please pause the video now and read this on your own. And also, before we begin, if you like my content, please click like and subscribe below. I release these kind of coding algorithm videos on almost a daily basis. I also release React tutorial videos. Anything related to coding, you will find it here on this channel. So please subscribe. Anyways, on with this algorithm here. How bubble sort works, pretty much, I'm not going to read this crazy directions here, but how bubble sort works is we compare two adjacent ones and the bigger number sort of bubbles up. So we do 1 and 4. Is 1 bigger than 4? No. So we go to the next one. The next pair. Is 4 greater than 2? Yes. So we flip these two. So we get, let's see, 2 and 4. Now we compare these two. Is 4 greater than 8? No. Is 8 greater than 345? No. Is 345 greater than 123? Yes. So 1, 3, 3, 4, 5. The bigger numbers kind of bubble up as you will. So 43, 345, they flip, they flip, they flip, they flip. And if you could notice at the end, the very highest number at the end of this first iteration, the very highest number, this guy, will end up being at the very end like so. And then we go back to the beginning and we start doing the same thing again. Is 1 greater than 2? No. Is 2 greater than 4? 4 greater than 8? 8 greater than 1, 2, 3? We keep on, and then whenever we find one that it's greater, then we flip it again. However, we go to the end, but we don't need to compare the last one because after our first iteration, the highest number is kind of locked in place in the last element. So as we go through these iterations over and over again, we got less pairs of numbers to compare with, right? Hopefully that makes sense. If not, please again, read this direction. And guys, if you guys haven't tried this one on your own, please pause the video now, try it, and come back to this video to show you, to look at how I do this. Okay, so let's begin. I'm gonna kind of ignore the comments here, erase that. And I will show you guys maybe a couple of different ways that we could refactor the code after we solve it as well. So we first need a for loop. As a matter of fact, we're gonna need two for loops, one inside each other. The first one keeps track of which iteration that we're on, meaning we compared, put the highest number in the last index, and then we kind of lock that in place. That's our first iteration. We go back to the beginning. We start comparing everything again until we get to the second last number here, and then we lock the second biggest number in place. So we have to somehow keep track of those iterations. I'm going to call those iterations I, and that will be our outer loop. So we will say for let I is 0. We're going to do a traditional for loop. I is less than array.length. However, how many iterations of that do we need? Do we need all is it the same as the length of this iteration? It's actually that minus 1 because we don't have to compare the last time. So it's actually going to be array.length minus 1 for this one, and then I++. Hopefully that makes sense. Now within the inner iteration, we're going to use J. J starts from beginning every single time. So we start at 0. And what J will do is go up and start comparing the one adjacent to each other. So J will go to array.length minus 1 again. Because once J gets to the second last one, you don't need to compare it with the last one. Once you get to the last one, he doesn't have the next one to compare with. So all you got to go is to the second last one. So array.length minus 1. But not only that, depending on which I you're in, we lock the highest number in place after the first iteration, right? So once we get to this number for our second iteration, we compare with 92. And then we don't need to compare this one with the last one anymore because that one's already the highest number and is locked in place. So what we can do for that is do minus I. I will be 0 in the beginning, so we're not subtracting anything. But in our first iteration, our second iteration where I is 1, I is 1 now. So we go we let j go to the -1 again. So j will only go to here, and then he will compare it with the second last one, and then switch if he needs to, and then lock that one, and then I will increase by 1. Okay, so let's increment j by 1 like so. Now within here, remember what we said, we're gonna compare the current one with the next one. So let's do if the current one, which is array at j, is greater than the next one, j plus 1, then we want to flip them. So the typical way to flip things is we first got to store one of them in a variable called, maybe we could call it temp. We'll do array at j, and then array at j will equal array at j plus 1. And then finally, array at j plus 1 will now equal temp. Okay, so if we have coded this correctly, and I didn't actually, you see this squiggly line I'm seeing here, I'm using the array variable wrong. It should be the forward array. So I'm going to highlight all of these and just replace all of them with array, like so. Okay, so if everything is worked out as planned, then this should sort this properly. Let me get the original array back. Paste it over here, and let's console log the result of this, just to make sure that we are on the right track. I'm gonna run the code, and it appears that it did sort it correctly. So this is good. Let's just make sure that Freecodecamp is happy with the solution. Why do I have this weird space here? Let's get rid of that. Might as well get rid of this space here too. Why not? I'm gonna grab all this, paste it in here, run the tests, and we pass. Okay, so let's think about a couple ways that we could refactor this. So do you see how we're messing with a temp variable here? Actually, we don't need to do this anymore. The way we can flip in place is just make arrays like this, make an array symbol like so, and just put the ones that you want to flip. Array at index j, comma, array at index j plus 1. I want to flip them around, and you just flip them on the right side, like so. That will replace these 3 lines that we have here. And I could prove it to you. Let's run the code again. And it is flipped, like so. So that's one thing we could do. Now the second thing we could do is purely optional, and it has to do with whether this function is a pure function or not. So what a pure function means is a pure function shouldn't change the parameters that you give it. Let me show you guys what I mean by that. Let's, instead of calling bubble sort with this big old array here, I'm gonna extract that to a variable. We'll say const r is equal to this big old thing. And instead of calling bubble sort upon this big array, we'll just use it upon our variable. Okay, now we run the code and it is sorted correctly again. However, let's console log array afterwards, our original array. So this bubble sort returns a new array, right? However, if we console log the old array, if you see they're actually the same, meaning our old array has been mutated because of this function. So it is not a pure function because it mutated our input. So the question here doesn't tell us to make this a pure function. So this is not one of the criteria. However, it bugs me as a functional programmer whenever we mutated input like this. So one way we could rectify that is just to make a new array variable before we begin the sorting. Make a shallow copy of the array parameter. So I'm gonna call this one just R. And the way that you make a shallow copy of an array, this is probably the easiest way, is just to call the slice method on it. That will give you a shallow copy of the original array. Now we just gotta be careful. Wherever we use array from now on, I'm gonna just replace that with our R variable like so. So now if I run this where I console log the result of the bubble sort, and I also console log the array afterwards, let's see what we get now. So if you look, the function call sorts the array, but our array variable is still the original array that we fed it. So this is a pure implementation of bubble sort. Let's see if Freecodecamp still likes this solution. Bring this over here. Run the tests, and we still pass. Okay, guys, so that was bubble sort today. Hopefully, you guys like this. So tomorrow or whenever we make these algorithm videos next, we're gonna be doing the selection sort. So I'll see you guys then. Remember, subscribe to my channel to get more coding videos like this. And happy coding. I'll see you guys next time.